Good morning. Today I am discussing about chemical equilibrium. So what is chemical equilibrium? In a chemical reaction which is reversible, if rate of forward reaction becomes equal to rate of backward reaction, then the reaction is said to be in equilibrium. Okay, so consider a reaction A plus B gives C plus D. Here, this arrow represents forward reaction and this is the backward reaction. At equilibrium, what happened? Rate of forward reaction equals rate of backward reaction. Then the reaction is said to be in equilibrium and the reaction is taking place in a chemical process, reversible chemical process. So, this equilibrium is called as chemical equilibrium. We can take one example, Haber's process, that is manufacture of ammonia. H2 plus 3N2 gives 2NH3. Here, the equilibrium is attained at high temperature and pressure. Okay. So, at high temperature and pressure, rate of forward reaction becomes equal to rate of backward reaction. Also, at chemical equilibrium, there will not be any net change in the composition of products and reactants. Net change in the composition. That means the concentration of products and reactions have a constant value. If we take an example, let us take H2 plus I2 gives 2HI. The graph is given here. That is time along x-axis and concentration along y-axis. Okay. In the case of products, what happens as the reaction proceeds? The concentration of the product increases, reaches a constant value. Okay, this is a constant value, then it again increases. Similarly, in the case of reactants, what happens? The concentration of reactants decreases, reaches a constant value and it again decreases. Okay, so from this graph, we can see that this is the point at which equilibrium is attained. So, at equilibrium, what happens? The concentration of products and reactants are constant. Reactants have a constant value. Okay. This much about chemical equilibrium. Law of mass action. Law of mass action is a quantitative relationship between rate of the reaction, rate of the chemical reaction and the concentration of reacting species. And it was suggested by Goldberg and Weige in 1864. Okay, and this law states that at constant temperature, what happens? The rate of the chemical reaction, is directly proportional to the molar product of the molar concentration. Product of the molar concentration of reacting species. Reacting species at a given time. Okay. Now, rate of chemical reaction can be represented as R and R is proportional to the concentration of reactants. So, this will be the reaction. Okay. So, A and B are the reacting species. Okay, A and B gives product. So, rate of the reaction is directly proportional to the product of the molar concentration of the reactants, or we can write R is equal to some proportionality constant into concentration of the reactants. Okay, product of the concentration of the reactants. Now, if we take the reaction having a coefficient, okay, this reacting species or reactants having coefficients, so the relation will become R is equal to K into A raised to A into B raised to B. So each concentration term raised to the power of the coefficient of the reacting species. Okay, this much about law of mass action. Characteristics of chemical equilibrium. First point, chemical equilibrium is dynamic in nature. Second point, chemical equilibrium is established from either side. It is established from either side. Then, in the presence of a catalyst, what happens? The state of equilibrium is become faster, but it will not alter the state of the equilibrium. Okay, faster the state of equilibrium, but will not alter the equilibrium. Next, fourth point, at equilibrium, pressure, concentration and density becomes constant. Pressure, concentration and density becomes constant. Okay, pressure, concentration and density becomes constant. Now, temperature is constant at chemical equilibrium. If temperature changes, what happens? Equilibrium constant also changes. Okay, temperature is constant, but if temperature changes, equilibrium constant changes. Next point. If temperature is constant, but pressure and concentration is altered, what happens? Temperature is constant, but pressure and concentration is changed. What happens? If it is altered, what happens? The reaction will shift into the direction either in forward or backward reaction to alter or to nullify the change in pressure and concentration. Okay, shifts in the direction to nullify the change. To nullify the change in pressure and concentration. These are the important characteristics of chemical equilibrium.